On purpose, I'm going to try to avoid all of this challenging language and terminology and symbols. I can look at this pattern. I know that I can add 3 to each thing, because this is kind of, just counting up by 3s. We've known our multiples by 3 for quite a while now. Now, looking at the difference of this, I know that the difference is 3. And using the word difference, that's not too crazy to me. All right, D. D is going to be 3. I'm pretty confident that D is 3. And the letter choice of D makes sense to me. Now I'm going to talk about this being the now term. And when I say now, I mean that's the one I'm looking at right now. And I'm going to talk about 6 being the next term. And this is all red because I'm just talking it out. So I know that if I want to get the next term, which would really be 6 in this problem, I can take the now term of 3 and just tag on the difference. So if I wanted to get the next term, all I would have to do is take what I have now and add on 3. So if I wanted to get 21, I could take 18 and add 3. If I wanted to get 18, I could take 15 and add 3. So if I want to get the future term, I can take what I currently have and add 3. Now usually where I'm at now, maybe it's just x. And so that I can tell my next x apart from the one that I have now, maybe I would call this x sub 1. Well, the one right after 1 would be 2. So I would call this x sub 2. And I would add on d. So if x sub 1 is 3, then I can get the second value of 6, which would be x sub 2, by doing x sub 1 plus 3. I could also get the third term if I took the 1 just before it and added on d. And we'll see if you can figure out what would go here. If I wanted to figure out the 100th term, I would add on d to something, but what number would I write here? And if you've thought this out to yourself and you've thought, well, it would be 99, then I would take the 99th term and add on d. And I've been using x because I think it's something we're more comfortable with, but let me go ahead and replace these x's with the letter a, because in the presentation of a lot of these types of problems, we're going to deal with a sub 2 and a sub 1, a sub 3, a sub 2, a sub 100, and a sub 99. And usually if we don't put something into practice ourselves, go ahead and repeat this out loud. A sub 1. Do it again and say a sub 2. So now let's deal with these words. Each term of an arithmetic sequence after the first term, we got to be given the first one to begin with, can be found by adding the difference to the preceding term. So it can be found as follows. Here's a sub 1. That's the first guy. I got a comma. I can find the second guy by taking a sub 1 and adding d. I can find the third guy by taking a sub 2 and adding d. The fourth guy by taking a sub 3 and adding d, where d is the common difference. A sub 1 is the first term, a sub 2 is the second term, and so on. So let's see if we can do this, using all these letters and everything. So let's just write down the arithmetic sequence, 74, 67, 60, 53, ... Now we can assume that this is an arithmetic sequence because they told us it. But it's good to be a little bit thorough. And so we'll do what we did in the previous problems and realize that from all of these terms, I'd subtract 7 and get the next guy. So this arithmetic sequence represents the amount of money that Tiffany owes her mother at the end of each week. So I guess she's paying her mom $7 a week. And then we're told to find the next 3 terms. So as we find the next 3 terms, we can just put a comma, but go ahead and put 3 blanks there so that it coaches somebody through what you're doing. And then we'll do 46, 39, 32, because we're just subtracting 7 every time. And so that we finish this problem, we're good to go. It's not a bad idea to kind of look at the pattern and be like, well, I'm subtracting 7, 1, 2, 3, 4, 5, 6 times. And so that means I'd really be subtracting 42. And if I take 42 away from 74, the further I get into the pattern, it's nice to check that to make sure that things all jive. Now we're not going to get into problems where you have to do the actual writing of all this yet, but let's just talk about it. Here's a sub 1. Well, that's going to be my first term, 74. My difference is going to be, that's 7, but not just 7 negative. And the way that I would get the second term, a sub 2, would be by taking my first term, a sub 1, and then adding the common difference, d. So if I wanted to know what a sub 2 was, I would have to take 74 and then add a negative 7 to figure out that a sub 2 is 67. You'll have to use this notation soon. It's just that we were talking about this and I want to make sure we don't get too far away from it before you get to apply it. So I'm showing you what it looks like. Find the next 4 terms of the arithmetic sequence. Let's make this an OYO problem, and then I'll do the same thing in the last one. You'll see my answer in 5 seconds. Pause the video if you didn't. Compare your results with mine, and I always try to find creative, easy ways to check this, and I noticed that, well, adding 1.5 twice is the same as adding 3. So 9.5 to 12.5 is adding 3. So that means that if I focus on the whole numbers, 11 would go to 14, would go to 17, and then to 20. And that's just kind of a nice way of checking a problem that involves decimals that sometimes makes me a little bit less sure of myself. Back to the whole thing I was going to talk about. Well, the first value, a sub 1, is 9.5. And that means that I'll need the common difference of 1.5 to figure out the next term. And so once again, if I want the second term from the first, I'd have to add d to a sub 1. So if I want a sub 2, I'm going to take 9.5 and I'm going to add 1.5, and lo and behold, doing it this way, you would also get that value of 11. If you didn't write your decimals for 17 and for 20, no big deal. Just kind of nice to write it to help with the pattern. Before we get into the next types of problems, we'll stop this, so this is a short and sweet one. I guess that's kind of not true. It's no shorter than most of the other videos.